In this video we will talk about IPv4 addressing, and first of all let's see why we need IP addresses. Well, it's for the exact same reason of why you need a home address. So people that they know you, in case they want to send you a letter or a package, they should know how to reach you. So let's take this example. In this picture we have a person which is trying to order something from Amazon.com. Once he decides on the product that he will want to buy, it will gonna be asked to fill out some kind of shipping address. And in the shipping address, he will put his home address. Like, for example, the country is US, state California, city Irvine, let's say, the street will be Baker, and the number will be, let's say, 14th. And with this information, once the online shop will see your shipping address, after they will pack the package, they will send it via courier. Let's say that in our case the courier, it's the US post office. So what will happen? The online shop will send the package to the post office. Let's say that the post office is in New York, and this post office is in California. And once the package reaches the New York post office, they will check the shipping address, which is for the California state, and they don't need to read any further, because once they will see California, they will send it automatically to the post office in California. Now in California, because the city is Irvine, it will send it to another post office. Let's draw another one here. And the post office in California, it will send it to the city Irvine. Now in the city, they will gonna check the street and the number. And so the package, it will reach its destination. Same happens with IPs. You need some kind of IP address to identify yourself in the network. So let's say that this user has the IP address of A, and Amazon will have the IP address of B. And along the path from his city Irvine to California to New York and then to the destination, there will actually, instead of post offices, we will have routers. These routers will sit at the network layer in the OSI model or the internet layer in TCP/IP. So on this layer, we will have routers, layer 3 switches, firewalls, or end hosts. Now usually you're not using your firewalls or end hosts to route the traffic. Mostly you will use routers, and in some cases you'll use also layer 3 switches. The IPv4 addresses will start from all zeros to all ones, and here we have the decimal representation, all zeros, and also here we have the decimal representation for all ones, which of course include all kinds of possible combinations with zeros and ones, or all zeros or all ones, as you see here. Now this space, it got split in the following way. In a class A, a class B, a class C, a class D, and of course a class C. To identify the class A, we will have the first bit always equal to 0. And the rest that you can see here with X, they can take any kind of value. So that means we will have from 0 to 127.255.255.255. And of course, if you want to represent this one in binary, you can write it in the following way. And the end will be 0 because we have we have class A, and the rest will be all ones. From 128, we will have class B, in which we will have the first bit 1 and the second one will always be 0. This means 128.0.0.0 to 191.255.255.255. And if you want to represent this one in binary, you can do it like first bit always equal to 1, second bit always equal to 0, and the rest are all zeros here, to 191. 191, it's 1, 0, and the rest are all ones. From 192, we start the class C address, where the first two bits are always equal to 1, and the third bit is always equal to 0. And class C starts with 192.0.0.0 to 225.255.255. And the binary representation is first two bits always equal to 1, and the third one is always equal to 0. To 1, 1, 0, and the rest are all ones. In class D, we have the first 3 bits always equal to 1, and the fourth one is always equal to 0. And in class E, we have the first 4 bits always equal to 1, and the rest can be anything. Now, class D, it was dedicated for IP multicast, and class E is dedicated for experimental use only. From classes A, B, and C, we also have some reserved spaces like 0/8. This one is reserved. I have never seen an IP address which starts with 0, for example. The 10/8 network is dedicated for private use only, the same as the subnet with 172.16/12 and 192.168.0.0/16. These 3 are used only for private use only. And from class E, we have the broadcast IP address, which is all ones. And here we have the link local range. Let's say that your PC doesn't have any connection to any kind of network. By default, it will take one random IP address from this space. And over here, I actually did a small mistake. I have no idea if you noticed. Between this range and this range, I should have squeezed another subnet which is reserved and part of the class A. This one is 127.0.0.0/8 and is used only for IP loopbacks. This range is defined by the RFC 5735. And this range has local significance only. The use of this range for PCs is that you can test your TCP/IP stack to see if it's properly installed on your system. So for example, if you're gonna ping any kind of IP address from this space, you should receive a reply. Let's try to test it right now. Let's try 127.0.0.1. And as we thought, we are seeing the replies here. Let's try another IP address from this subnet just to see how it works. And again, the replies are coming to us without any issues. Another use for these IP addresses are when you're trying to run a web server, or in my case, I have a Plex server, and locally, because I'm running my Plex server on this laptop, locally, I can access the service using this IP address and this TCP port number. If I will try to access my server from another PC in the network, I will do it via the real IP address that I will receive once I'm connected to the network. So let's say 172.16.32.10 on the 32.400 port. When you're going to download the flashcards, you're going to see the updated version with 127.0.0/8 squeezed between these two ranges. The rest of IPs that you will not see specified here from these three classes are public IPs, and they are listed only by IANA. So if you're going to click on this link here, we will reach iana.org, and over here we can see the IP addresses. And if we were going to click on the IP addresses, we can see that the registry where you can ask for an IP address space are divided by regions: for North America, for Latin America, for Africa, for Europe and Russia, and Asia Pacific. Down below we can see the address space for IPv4 and IPv6. Let's go to IPv4 address space, and here you see that 0/8 is reserved, as I've told you. From here, most probably you will recognize these ones, and DoD, AT&T as well. In the previous video, we talked about binary conversions, and the IPv4 generator. So let's generate 5 IP addresses, and we have these ones here. As a homework for you, I advise you to practice something like 10 or 20 IPs and figure out from which kind of class they are. Let's take the first IP. And from all the IPv4 addresses, we will check only the first octet. And this one is 97. Let's make our chart somewhere over here. And we can write 97 like a 0 here. And if you're seeing the first bit 0, naturally is class A. So this IP over here belongs to class A. Moving further to 58, 167.75.106. In this one, of course, the first bit will gonna be 0, so again class A. In this one we have 255 as the first octet, and 255 can be written like 1, so we'll have 255 minus 128, 127 minus 64, or 132, then we will have another one for 16. As soon as I'm gonna reach 4 bits with all 1, naturally is class E. Let's take on 166. For 166 we have 1, for 128, for 64 we will have a 0. As we are seeing here the first 2 bits in the octet, 1s and 0, it's naturally class B. Then in the last one we have 209 as the first octet, so we'll have 1 on 128, a 1 for 64, a 0 for 32. Over here we can stop because in the first 2 bits we have 2 1s and the third one is a 0, so naturally it's class C. Anyway, I advise you to do something like 10 using the IP generator. Just a couple of minutes ago, when I presented you the reserved subnets from class A, B, and C, you have seen a /16, /12, and you might wonder yourself, what are those? Well, these are actually subnet masks. So for example, when we had the 10/8 network, this one, the /8 is the subnet which defines what kind of bits are used for hosts and which ones belong to the network part. And every time you'll see here a /8, a /16, that means that the first 8 bits are all ones, or either for /16 the first 16th bits are all ones. So let's take the first one here, and considering that the first 8 bits are all ones, we can write them like so. This representation in decimal is actually 255, because in the first octet we have all ones and the rest are all zeros. When we have subnet mask of /16. The first 16th bits will be all ones and the rest will be all zeros. And the decimal representation for this is 255.255.0.0. And as I've said, these bits belong to the network. Network bits, and these ones are the host bits. Please stay tuned for the next video when we will gonna get our hands dirty and we will see how we can put these bits to use. Don't forget to subscribe, thumbs up if you like the video, and talk to you guys in the next one.